Alright, these instructions say find the zeros for the polynomial function and give the multiplicity for each zero, state whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. So to find the zeros, you set each parentheses equal to 0, so I'm going to say x plus 2 equals 0 and x plus 6 equals 0. Now I'm going to solve those. So this first one gives me x equals -2. The second one gives me x equals -6. Then on each of these we want to write the multiplicity, so I'm going to write m for multiplicity. This factor that's x plus 2 right here, what we do is we look at the exponent of the parentheses. That has no exponent to start off with, which means that there's really a 1 there. So this has a multiplicity of 1. For the x plus 6 factor, we have an exponent of 4. So its multiplicity is going to be 4. And then last, we want to say whether the graph touches or crosses the x-axis at each of these zeros. If the multiplicity is an odd number, like this first one, that means that it crosses. If the multiplicity is an even number, like the second one, that means that it touches. So this right here is our set of answers. On number 2, it's going to work out similarly. And on both of these, we would just ignore that, like the 5 in front on one, the -3 in front. If there was an x in front as well, we'd have to do something with that, but there's not, so we'll just ignore that -3. So we're going to do x minus 3 equals 0, x plus 4 equals 0. So that means that x equals 3 and x equals -4. Then we're going to do the multiplicity. So this first one has an exponent of 1, so its multiplicity is 1. The second one has a multiplicity of 3, because its exponent is 3. Both of these are odd, so both of these, the graph crosses at that point. The next section has us using the leading coefficient test to determine the end behavior of the graph of the polynomial function. So you should have in front of you from the 11.1 day 1 notes the leading coefficient chart that we made. What we do is we look at the very first term and we say, okay, this is a positive term and it has an even power because it's to the 4th power and that's an even number. And we look at our chart for positive even power and we say, okay, that means that it rises to the left, rises to the right. On this next one, we look at this right here. It's a negative number and it's an even power because it's to the 4th power. So negative even power means it falls to the left, falls to the right. Number 5, we look at 5x cubed and we say that's a positive number. It's an odd power. So if it's positive and it's an odd power, that means that it falls to the left, rises to the right. And number 6, we would say negative odd power. So this one rises left, falls right. Now we want to determine whether the function is even, odd, or neither. And so to do that, we look at the exponents. On this first one, we have an exponent of 3, an exponent of 1. 3 is an odd number, 1 is an odd number, so this is an odd function. On the second one, our exponents are 4 and 3. This one is an even, this one is an odd, Since it's a mixture of the two, we say that it's neither. And, looks like I didn't do a very good job of putting an example on here of even. So this is odd, so it's odd. If we add something like x to the fourth plus x squared, that would be even. On number 10, the first thing I want to do is I want to change what the equation is. So mark out the equation, and this is the one that we're going to use instead, because the equation that was on there doesn't work as well as whenever you get to the factoring part, it's not really going to work. So this is the equation we're going to use instead. So we're going to graph the function on 10 using the following information. So part A, to find the end behavior, you look at the very first term here. It's a positive term and it has an odd power, so you look at your chart and you see that the end behavior falls to the left, rises to the right. So that's part A, and so that's going to help us graph here in a sec. Part B is where we have to factor what we're given with, and so this is the part where if you use the original equation given to us, you'll have problems. If there are 4 terms, like in this case, you factor by grouping. So we look at the first 2 terms and we say, what can I take out of both of those? We can take out an x squared, and if we take out that x squared, we're left with x plus 6. The second part of this, you look at what they have in common. The only thing they have in common is that negative. So we're going to take out a -1, because then it leaves us, if we take out the -1, with x plus 6. When we factor by grouping like this, we want what's in parentheses to match, because if they do, we can factor out what's in parentheses. So we can take the x plus 6 out and write what's next to it, what's left over, if we take out the x plus 6, which is x squared minus 1. But that's not all. We can keep factoring, because x squared minus 1 factors into x plus 1, x minus 1. Well, how do I know that? You can think of it one of 2 ways. Anytime you have a minus sign, 2 terms, and both can be square rooted, you can split it up into x plus the square root of the number and x minus the square root of the number. Or think about it like there's a plus 0x here in the middle, and so then we're looking at, what do I multiply together to get -1 that will add to give me 0, so that that middle term gets canceled out. Once we have this all factored out, we set it equal to 0 and we solve. So that gives us x plus 6 equals 0, x plus 1 equals 0, x minus 1 equals 0. You are going to have to subtract 6 on the first one, subtract 1 on the second one, add 1 on the last one. And then we look at multiplicity. Multiplicity is the exponents of our terms up here when we set equal to 0. So all 3 of these have a multiplicity of 1. And the reason that's helpful to us is odd multiplicities tell us that the graph crosses the x-axis at that point. Even multiplicities tell us where the graph just touches the x-axis and then bounces back. So at all 3 of these points, we're going to cross. Part C, to find the y-intercept, you put a 0 where x is in your problem, your original problem. You can put it in the factored form, but this is easier because all of this stuff except the -6 goes away. So our y-intercept is -6. And last, part D, even, odd, or neither tells us our symmetry. So if we look, we have an odd exponent, an even exponent. This would be odd and this would be even. So since we've got a mixture, it's neither even nor odd, which means that there is no symmetry in this graph. So let's plot this. We are going to first plot the zeros we found. -6, -1, and then, oh, that's not -1. That's not the right -1. -1 on the x-axis, because these are x-intercepts. -1 and then +1. Okay, now from there we look at our end behavior. It falls to the left. So from this farthest left point, we have to go down and to the left. It rises to the right, so from our farthest right point, we have to rise to the right. Since it crosses at each of these points, then I can follow this graph through and say, oh, it has to go through, it has to come through this, and actually then we also have a y-intercept of -6. So we got to go all the way down to -6 and then come back up. This is not by any means a perfect graph, but it gives you an idea of the basic shape of what this would look like. If I could go back, I would actually make this part straighter because of the way that turned out. So that's number 10. Another one like number 10, now number 11. This one works fine. We're not going to have to change it, so that's nice. And we're going to start off with A, the graph's end behavior comes from the leading coefficient test. So you look at the first term, it's a positive term and it has an even power. We look at our chart and we see that means that it rises to the left, rises to the right. That's from our chart. Then we go to part B, and part B is where we factor. So we're going to take x to the fourth minus 9x squared. We see what they have in common since there's only two terms here. They both have x squared that we can take out, and if we do, the first thing is left with x squared, and then the second part of this, well, the x squared is going away, so that leaves us with minus 9. But that's not all. We can keep factoring the x squared minus 9 because I can square root both of those and it's a minus sign. It factors into x plus 3, x minus 3. Or another way to think about it is if it's like there's a plus 0x there. So what do I multiply together to get -9? That will add to give me 0. And the only answer we have for that is plus 3 minus 3. We set this equal to 0 and solve, which means I have x equals 0. The x squared, the squared part of that means this has a multiplicity of 2. And if I have an even multiplicity, that means that my graph touches at that point, x equals 0. Then I set x plus 3 equal to 0, which gives me x equal -3, and x minus 3 equal to 0, which gives me x equals positive 3. Both of these, the parentheses have an exponent of 1, which makes our multiplicity 1, which means that both of these points we're going to cross at. Okay, part C, we have to find the y-intercept. To do that, we put a 0 in everywhere the x is in our original equation, which cancels out both of those terms and leaves us with 0. And then D, we look at the symmetry. So we have an even power and an even power, which means this is an even function. Even functions have y-axis symmetry. So if you were to fold this graph along the y-axis, which is the one that's going up and down, both sides of the graph should look the same. So let's graph this. I need to put my zeros. So x equals 0, x equals -3, x equals positive 3. Then I need to do my end behavior. So we're rising to the left, which means from my farthest left point I need to go up. We're rising to the right, so from my farthest right point we need to go up and to the right. In between here we cross at -3 and positive 3, so I have to go down after I go through that point on both of those. But I have to come up and touch the middle and then go back down again. So that gives us what looks like a W. Just keep in mind that these graphs are supposed to be curvy, so you'd want to try to make it look like this. It's hard to see on my graph, but you want to make it kind of curvy. And it's not a perfect graph by any means. It does kind of look like if you fold it on the y-axis it would be the same on each side, so that's that graph. Same kind of problem as the one before this, so we would do synthetic division with 3, 1, 2, -9, -18, drop the 1, multiply, add, multiply, add, multiply, add, x squared plus 5x plus 6 equals 0. Factor. What multiplies C at 6 that adds C at 5? That'd be 2 and 3. So x is going to equal -2, -3, and from the problem, positive 3. use the rational zero theorem to list all possible rational zeros for the given function. So what we do on these is we take the factors of the last number and we put them over the factors of the first number, which in this case is a 1. So factors of 7 are 1 and 7. The factors of 1 are 1. So we put each number on top with each number on bottom, and we put a plus or minus with them. So plus or minus 1, plus or minus 7. Those are our possible rational zeros. Number 15, factors of 8 over the factors of 2. So factors of 8 are 1, 2, 4, and 8. By factors I mean what can I divide evenly into 8. Factors of 2 are 1 and 2. So we're going to put each number on top with each number on the bottom. So 1 over 1 is 1. 1 over 2 is 1/2. 2 over 1 is 2. 2 over 2 gives us 1. So we already have that written down. 4 over 1 gives us 4. 4 over 2 gives us 2, which we already have written down. 8 over 1 gives us 8. 8 over 2 gives us 4, which we already have written down. So these are all of our possible rational zeros. On 16 and 17, we have to find all the zeros. So we're going to start off by listing all the possible rational zeros. So on this one we have 12 over 1. So factors of 12 are 1, 2, 3, 4, 6, and 12 over the factors of 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So we want to use synthetic division. We want to guess. We'll try to guess what we have for zeros. So I'm going to guess 1. And I'm going to do synthetic division, and if I get 0 at the end, then I know I did it right. Or I know I guessed right. If I don't, then I have to guess a new one. So drop the 1, 1, 4, 4. Well, that's not where I wanted a 0. Right, so 1 is out. And then I could do -1 if I wanted to. How about 2? Haha, 2 works. Alright, so that means that I'm going to put my answers up here. X equals 2 is a 0. Now we're going to say that this is x squared plus 5x plus 6 equals 0. We're going to factor that into 2 parentheses. So what multiplies to get 6, that adds to get 5, 2, and 3. So that means x plus 2 equals 0, x plus 3 equals 0. So x equals -2 and -3, and then it already equaled 2 from our synthetic division. Alright, we want to do the same thing on 17 that we did on 16. So we want to find the rational zeros. So factors of 6 are the factors of 1. So 1, 2, 3, 6 over 1. It's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So let's do some synthetic division. Hooray! Guessed right. So x equals 1 is an answer. That gives us x squared plus 7x plus 6 equals 0. We're going to factor. And what multiplies to get 6, that adds to get 7, 6 and 1. So we would say x plus 6 equals 0 and solve, x plus 1 equals 0 and solve. That gives us -6 and -1, and that answer choice looks like A. Number 18, to find the vertical asymptotes, we set the bottom of our fraction equal to 0. So x minus 2 equals 0 means that x equals 2 is our vertical asymptote. On 19, set the bottom equal to 0, that means x equals 0, and x minus 3 equals 0. So that means x equals 3. These two things are vertical asymptotes. 20, horizontal asymptotes. So we had kind of a chart thing in our notes. This is 11.3 day 1, and so we definitely would want to have that available to look at for this. So you compare the degree on top, the power on top, with the power on bottom. So on top I have x to the first power, on the bottom I have x squared. So since 1 is less than 2, the top is less than the bottom, which means our horizontal asymptote is at y equals 0. On 21, these are both squared, so the 2 degrees equal each other, the powers equal each other. What we do is we take the numbers from in front. 4 over 2 is what y equals, which means y equals 2, if I simplify. And last, we have 3 and 2. 3 is bigger than 2. The top is bigger than the bottom, so there is no horizontal asymptote. Alright, on 23 and 24 we graphed the rational function using the following information. Part A, to find the x-intercepts, you set the top of your fraction equal to 0 and solve, which I divide by 2 on both sides and get that my x-intercept is x equals 0. Part B, to get the y-intercept, you put 0 everywhere that x is. That gives me 0 over -1, which is 0. And so for as far as my graph goes, that means I've got a point at 0, 0, because my x and my y-intercept are both 0. Part C, we want to find the vertical asymptotes. If we haven't already at this point checked, we would want to check and make sure we were factored on top and bottom and that nothing cancels out. But the top and the bottom are fine on this, and nothing cancels, so we set the bottom equal to 0, add 1 to both sides. That gives us a vertical asymptote of x equals 1. So at 1 for x, I need to do a vertical line that is dashed, because that's how we do vertical asymptotes. Alright, so now part D. To find the horizontal asymptote, you compare the top and the bottom, and all you need to worry about is the first term on each. And you think about the exponents the x's have. In both of these cases, the x's would have an exponent of 1. Since they're equal, we look at our chart, t equals b. So the top equals the bottom, which is when we basically take those two terms. Here, I'll put it over here with d. We take those two terms we've got and then we simplify. The x's would cancel, which gives us just 2. So our horizontal asymptote is at y equals 2. So at 2 for y, I need to draw a horizontal asymptote, which is dashed. From here, if you've practiced enough, then you should already have an idea of what the shape looks like, and because of this 0, 0 here, it's really helpful. If I'm at 0, 0 here, then as I go to the right, I need to get closer and closer and closer to that asymptote. As I go to the left, I need to get closer and closer and closer to that asymptote. Then the rest of my graph, if I end the closest to this asymptote down here at the bottom, then I'm going to be up here at the top of this asymptote, and I follow along those asymptotes like that. The other thing you can do is you can plot some points, like we could pick 5 or something like that, and we can plug it in up here to our function, 2 times 5 over 5 minus 1. That gives us 10 over 4, which you can find on your calculator. Gives you 5 halves, which is 2.5. So that tells us that we have the 0.5 comma 2.5. So you go over to 5, you go up to 2.5. We're pretty close there. So as long as we have the basic shape of the graph, then we should be okay. Alright, so 24. Same basic process here. Part A, we want to find the x-intercept, so we set the top equal to 0, and we get x equals 0. That's our x-intercept. Part B, plug in a 0 everywhere x is. That gives us 0 over -4, which is 0. So that's our y-intercept, so both of our intercepts are 0, so we've got the point 0, 0. C, okay, at this point, if we haven't yet factored, we need to. This is going to stay 3x on top, but on bottom, this factors into x plus 2, x minus 2. We check real quick and see, does anything cancel out? Nothing does, so we set the bottom of our fraction equal to 0 and solve. So that gives us x plus 2 equals 0, x minus 2 equals 0, so x equals -2 for the first one, x equals +2 for the second one. So these are vertical asymptotes at -2 and at +2. So we draw vertical lines, those two spots. Now we do our horizontal asymptote. Horizontal asymptote, go from your original equation and look at the first two terms. The exponent on top is 1, the exponent on bottom is 2, so the top is less than the bottom. 1 is less than 2. So you look at your chart and you notice that that means that our horizontal asymptote is at y equals 0. So along the x-axis, you want to draw a dashed line, and that can be difficult to get it to show up. So you want to do your best to show that you've really drawn a dashed line on top of the x-axis. So our graph, now we're going to have to go and plug in at least a couple points. Remember that a horizontal asymptote is only really an asymptote at the ends of your graph. In the middle, your graph can cross that point. So let's plug in something like, has to be bigger than -2, it's got to be somewhere over here. So let's plug in -3. So 3 times -3 over -3 squared minus 4. And you do that math real quick and get -9 over 5. Well, all that matters there is that when we plugged in a -3, which is here, we got a negative number, and that's actually almost -2, so that's a point about right here. So that means our graph is going to be down here going towards our asymptotes, as opposed to it being up here going towards our asymptotes. Then, if I end this asymptote here, if I end close to this asymptote here at the bottom, then I'm going to start this one up here at the top. And then what should happen is it should go through this point and do kind of a curvy thing like this and head down toward the asymptote. So see how it crosses in the middle? Even though we got a horizontal asymptote, it's just not a very good asymptote in the middle. And then since we ended down here at the bottom, we need to start at the top up here and graph towards our asymptotes. Now I would go ahead and check and plug in like +3 or 5 or 10 or whatever, something that's over here on the right side, just to make sure that it did what we really thought it was going to do. When I plug in 3, I get 9 over 5, which is positive, so that puts it up here as opposed to being down here. So we graphed it right. So there it is.